All right, here we go. All right, so guys, really quick, in the warm-up, we are going to be given another form of a quadratic equation today. Think about when you would graph a line. I could give you the equation of that line in slope-intercept, good old y equals mx plus b, or I could give you the equation of the line in standard form, ax plus by equals c. So a line had two different forms, so it's not uncommon for other types of equations to have different forms too. So we have been working with quadratic equations in standard form. That's what we're used to. Today I want to show you a second form. The second form is called vertex form. And the reason it's called vertex form is because the vertex is hidden right in the equation. So you don't have to calculate it. You don't got to do any of that negative b over 2a. The vertex will be right there for you to take right from the equation and start graphing. So if you ask me, vertex form makes this even easier because it's that much faster. The vertex is right there for us. All right, so first, I don't want you guys to forget standard form. So if you are in standard form and I asked you to find the vertex, how do you find the x-coordinate? Negative b over 2a, good. So that would be what? Just 6 over 2 times 1. What's 6 divided by 2? So we know the x-coordinate is 3. We plug 3 in to see who the y-coordinate is very carefully. And then anybody get a number for the y-coordinate? Fine. We know that the vertex for this quadratic equation would be at 3, 5. Okay. Well, now let me show you something else. In number 2, I told you to wait for me because I didn't know if you guys remember this or not. I gave you a mathematical expression. It is a parenthesis squared, degree 2, quadratic, and then you have to add 5. I asked you to simplify it. So if you simplify that expression, that means you have to get rid of its parentheses and combine like terms. Well, if you simplify this, watch what happens. Well, first of all, guys, I have to square this. What is the definition of squaring something? If you had to explain it to somebody, how would you explain what 5 squared is? Multiply it by itself how many times? Twice. So if I want to square this, I have to times it by itself 2 times. And then when I'm done with that, I have to add 5. All right, so guys, we have to multiply this together. Do you guys remember a little phrase from Algebra 1 called FOIL? Yes. This is a FOIL. If you want to multiply 2 terms with 2 terms, guys, it's not as easy as just what's x times 3? 3x. It's not as easy. This is x subtract 3 times another x subtract 3. So how do I multiply around all of this subtraction? Well, you FOIL. It's basically distribution. It's double distribution. So FOIL is a little phrase that helps you remember the order in which you should multiply. But at the end of the day, you're going to take the first term in the first parenthesis and you're going to distribute it to the second parenthesis. So guys, first we're going to do x times x. Anybody know what x times x is? X squared. You just times x by itself twice. That's x squared. Sometimes students want to say 2x, but remember, x plus x is 2x. X times x is x times himself twice. That's x squared. All right? Now you're going to take this and distribute him again. What's x times negative 3? Negative 3x.
Wait, can you put that in a calculator? And I'll do it for you?
No. Not these yellow ones. No. It won't do variables. But it's not going to be anything more complicated than x times x and x times 3. X times 3 is 3x. I don't feel like I've convinced you, Jake.
No, I got it.
Okay. All right. So that was the F and the O from FOIL. First, you multiplied the first and the first piece together and got x squared. That's it. Then you multiplied the x with the negative 3, the outside 2 pieces together. That's the O in FOIL. All right, since I've taken him and distributed to everything over here, we're done with him. Now we're going to go to the second term and distribute that to the second parenthesis. So what's negative 3 times x? Again, we get negative 3x. That's the I in FOIL. You multiplied the inside 2 terms together. And then we're going to take negative 3 and distribute him one last time. What's negative 3 times negative 3? Positive 9. And that is the L from FOIL. You multiplied the last 2 terms in each parenthesis together. And now all you gotta do is bring down the +5, and now we clean up like terms. That is an extremely typical Algebra 1 problem. So if you, and I'm not trying to be mean, I feel like I'm really on a roll here of sounding mean, but if you are looking at that like, Hardy, I don't know FOIL, then this is gonna make chapter 4 a little bit harder, because that is something they expect you to know. You toil your brains out in Algebra 1, you really do. So if you didn't foil in Algebra 1, that's a problem, because that is a skill they expect you to know inside and out. So we're gonna have to perfect that. Go ahead.
But what if you don't typically remember?
I know, but the thing about school is they do expect you to retain information. So the stuff I teach you today, people actually expect you to remember it later. It's a part of the learning process.
I never learned.
I know it. None of you. You guys don't remember what we did yesterday. I get it, all right? But they are expecting you to retain some of the information.
Every time I learn something, you do something crazy right after.
Well, that's the part of learning. You build on what you learn, right? Right. What do you lift the same weights every day, Darian? No, you increase them. You work the body, shock the body.
By like 5 pounds.
Well, okay, this is a 5-pound increase. All right, this is nothing.
No, this is like.
Stop it.
That's like a max.
Bianca, help me out here. We're fine. We know how to foil. All right. So either way, if we don't know how to foil, chapter 5 is going to review it. But they do. That is definitely a skill they expect you to really, really know. And I get it. You guys are in a tough spot with the way Algebra 1 ended. All right, now all we gotta do is clean it up. Do we have any other x squareds to combine? No. So we have 1x squared. Then we have -3x's and -3 more. I know we know how to combine like terms. How many x's are in this problem? -6x's. And then we have 9 and 5 as our two numbers. And they make what number? 14. Okay. So now you have a quadratic expression that is in standard form. I'm going to throw a y equals in front. Guys, look at who you got. Y equals x squared minus 6x plus 14. Who did I give you here? Exact same equation. You want to know why? Because that is vertex form of this quadratic equation. That is the exact same parabola as this and this. It's just written in a different form. And that's how you take something from vertex form and get it back to standard. You got to multiply it out. But this is what today's parabolas are going to look like. This is our new form. They are vertex form of a quadratic equation. They represent the same ones we've been doing. They're just written in a different way. And here's why we're going to love it. What vertex did we say this parabola had? His vertex is hidden in the equation. So when you are in vertex form, yeah, it's going to look weird, but the vertex is in the equation. You ain't got to calculate it. You're just going to take your x coordinate and your y coordinate and you're going to start graphing. So these ones graph a lot faster because you don't got to do any negative b over 2a and plug in to get y. The vertex will be right there for you to take from the equation.
Always those same.
Yes, it's the number inside the parenthesis and the number at the end, every time. Darian, there is one catch though, so we'll talk about that. All right, so here we go. Let me give you your notes for today. I know, it's always one little, like a half a pound increase, okay? This is a really big.
Yo, the 2.5 is like, yeah, they make it really like you're going.
It's fine, we're gonna be fine.
Hands on your face, man.
Stop it.
I mean, at least you're referring it to something I can.
Now, let me just say this before we move on. So obviously, we can take a vertex form and convert it to standard form just by multiplying it out. The reverse, though, to take standard form and write it in vertex form, that is something that I am told you will wait and see in pre-calc. I could teach you, but it's not a skill that I am told to teach you. It needs a process called completing the square, and that's not something that we usually do in the Algebra 2 CP. But you will see it in pre-calc next year if you move on. All right, here we go. Watch how easy this is going to be. Listen, I wish there was another option out there. I wish it wasn't the only class for you to take. But right now, it is.
The next thing we do is they're going to be building off this.
All of chapter 4 is about quadratic equations. Right now, section 1 is all about his graph. Standard form, vertex form, graphing. The next section that we do is all about solving a quadratic equation. And that's, let I tell you right now, if you leave Algebra 2 knowing something, it better be knowing how to solve a quadratic
So like
equation.
we're gonna be seeing
Equations, and then we're going to solve them for x.
the whole
Thing. We're going to solve it for x.
like the whole market period.
No, but it's a big chunk because we're going to do a lot of chapters. There's lots of different ways to solve them. All right. Oh, guys, really quick before I forget, the test that you have to take in March, I did find out the name of it. It's the NJGPA. Right now it's looking like March 14th. The email said March 14th to the 18th, but I think it's the 14th is our day. Either way, it ain't sooner than March 14th. That is our week. It sounds like it's going to be 2 math days, 2 English days. It said Algebra 1 and Geometry. It is a graduation requirement as of right now that you pass this test.
No way.
Wait, can you take a look at the test?
Let me tell you what I'm being told. Right now, there's always been a graduation requirement. COVID kind of messed that up. Like the seniors that graduated last year and the year before, they got off easy. They didn't have any, they canceled all state tests. So right now, so don't feel like you're being picked on, it is very common to have a state test to pass to graduate high school. When I was in high school, it was the HSPT, the High School Proficiency Test. Then they got all politically correct and you couldn't use the word test. So when I started teaching, it became the High School Proficiency Assessment. And then it turned into PARC, and then PARC became the NJSLA, and now the NJSLA has become the NJGPA or whatever. But there's always been a state test, so don't think you're being picked on. This is what I'm being told. You're going to take it in March of this year. If you do not pass it, you are going to be put into a class next year, like an extra, I'm assuming it's elective, math class, where a teacher is going to try to prepare you to take it again in the fall. If you don't pass it in the fall, then you start going through with that teacher an appeals process. You'll have some other avenue where they will prove that you know enough math to graduate high school. So I don't want you guys putting any pressure on yourselves. They gave us 2 practice tests to go over with you, but I'm just telling you right now, the PARC test was always difficult. The NJSLA was difficult. I don't expect this to be a walk in the park. So we got to make sure that we are doing whatever we can with the material we're doing now to prepare. And then that's it. I don't want you guys going home and, freaking out. But they are saying it's a graduation requirement, okay? So we're gonna try not to freak out about that and go from there. The practice test that I saw did have many type of quadratic questions on it. So I'm hoping that's a good thing for us. Stuff will be fresh in your mind. It's the topic we're doing right now, all right? But they did say they were cutting it at Algebra 1 and Geometry.
Wait, this is Algebra 1?
Is this, technically you end Algebra 1 usually working with quadratics and radicals.
I remember the foil.
So, yeah, the foil, that's something they would expect you to know, definitely, yes.
I thought you didn't pass the PARC. You can pass the SAT or something.
Sometimes the PARC, they came up, because not a lot of people passed the PARC, it was a difficult test. The PARC had other avenues of graduating high school, like if your PSAT score on math was high enough, that could count instead of a PARC score. In SAT, the ASVAB was a big one that they could exempt out of, like if you didn't pass PARC, but your ASVAB score was high enough, they let you graduate high school. I have not been told any other exemptions or policies they've made. They could. All right.
Can I still go to college if I'm not gonna?
Absolutely.
My guidance counselor came in today and she said that there was a science part too.
I'm just being told it's math and English, but if the science is, then they know more than me probably. I was told math and English.
If it was a science part, I would ace that.
Yeah. I don't know. All right. But here we go. So I just want to make sure you guys, as I get the information, I want to get it to you guys. All right. So the only thing I worry about when we start Vertex form is that you're going to forget standard form. Please don't forget standard form. We know it. We've been doing it since Thursday. Negative b over 2a. Get your y coordinates, start graphing. All right. So remember, no matter what form it's in, it's a quadratic equation if it's a degree 2 equation, right? The highest exponent on a variable is 2. Standard form is who we've been working with, and we know it looks like this. ax squared plus bx plus c. We know A is the number who tells us if it opens up or down. We know A is that number the pattern depends on. We know C is always our y-intercept and stuff like that. All right, the graph is still going to be a parabola. We're still graphing parabolas. The most important point on the parabola is still going to be the vertex. That's who you want to get first, and then you want to start creating more points from the vertex. Okay, so if you are going to be a quadratic equation in vertex form, then this is what you have to look like. This is the new formula. Y equals A is still your leading coefficient. He is still going to be the number way out in front who tells us if the parabola opens up or down, and he's still the number the pattern depends on. It doesn't matter what form you're in, A is our guy. All right, this is where it starts to get weird. It's going to be Y equals A times the quantity, the parenthesis, X minus H, quantity squared. H is just the variable they use. And then plus K.
Okay.
When you are in this form, it is vertex form. And that means your vertex is going to be the point HK. The X coordinate of your vertex is H. The Y coordinate of your vertex is K. This is the little gimmick, though, that you have to watch out for. The formula says that you have to be in X minus some number form. So X is part of the formula. The minus sign is part of the formula. So just H is your X coordinate. So let's just say it said this. X is part of the formula. Minus is part of the formula. So H is really just who? 2. So when you are getting your vertex, I'm just going to warn you that the X coordinate, this H, is always going to be the opposite of whatever number is written there. Because really, that's not part of the number. So when it says minus 2, the minus is not part of who H is. It's part of the formula. It'll just be 2. So the only thing you have to remember is that H, the number inside the parenthesis, that is your X coordinate, is always the opposite number than what it looks.
So there always has to be a minus sign, right?
Well, I'm not going to make you rewrite it, but yes, technically, by definition of the formula, it's always supposed to be X minus a number.
So technically it goes into a positive.
No, because if it's 2, then X minus 2 is just X minus 2. But if it's X minus negative 2, then it becomes positive. I'll show you. All you have to remember is that H is always the opposite.
So what is the one you just put up? Is that X minus 2?
So if the problem said X minus 2, that is X, that is minus, H is 2. The opposite of looking like negative 2.
So negative 2, okay, it'd be X minus minus 2?
Yes, because they would do this, Darian. X minus negative 2 actually turns to a what? A plus. So when it's a plus 2, it's the opposite of that because X minus H is negative 2.
So the top one is negative.
I don't know what you're saying. So the top one is 2.
No, I'm talking about like the actual answer would be negative.
Here.
No, the top one.
No, he would be 2. The opposite of what number is written. So it's going to say minus 2. So what would be the opposite of minus 2?
You crossed out the minus, so I thought it was...
I know, I'm crossing out the minus to say that it's part of the formula. But when you're just looking at it, it's the opposite of that number, just 2.
Wow. Like at first I got it, and now I'm confused.
Okay, well it's the opposite of whatever number is written there. Now, this is what I always say next.
I thought you were saying you have to...
50% of you are always going to make it the opposite number. 50% of you are never going to remember to make it the opposite number, and you never get the vertex right. It is the opposite of that number there. And the only reason it is the opposite is because it has to be written in X minus form. So when it's X minus 3, it's really just 3, because the X and the minus are part of the formula.
Okay, so you're not just don't even think about destroying the subtraction sign.
No, just for the love of God, take the opposite of the number there. I'm telling you why, because I like to tell you why, but all you have to know to do is take the opposite of whatever number is in that parenthesis. I don't have it in me not to tell you guys why. I have to tell you why. I don't mean to do it to confuse you. But at the end of the day, we're just going to take the opposite of that number. All right, so watch this. Are we ready? I don't know. All right, here is a quadratic equation in vertex form. So watch this. Hold. I don't mean to be a jerk. I want you to see this. That is vertex form, right? So A has to be the number in front of that parenthesis. Who is that assumed to be in this problem? No, what number is A assumed? 1. Beautiful, right? Anything's in front's not there, we assume it's 1. So now you know A is 1. So is this parabola going to open up or down? Up, it's positive. And if you're a pattern person, he's your guy. That is still the number you use with 1A and 3A and 5A and 7A. All right, now we need H. It says -6, so we're just going to say 6.
Oh.
And the reason is because X and minus are part of the formula, so H is just 6. Okay. And now K is always as is, so who's K? 1. So if H is 6 and K is 1, that means your vertex is HK, so 6, 1. Take them and go. Start graphing.
So you only opposite the H.
Only the H. K is as is. Only the number in that parenthesis is the opposite of what he looks.
Oh, there we go.
Okay? All right, let's try this one. Okay. Okay. Now this is what, Darren, this is exactly what you were saying. This is technically not vertex form because it's not X minus a number. But I could say that this is X minus who? -3 would turn to X plus 3. So now X minus who's H now?
3.
Three.
Oh,
X
-3.
minus H is -3. The opposite of what's written there.
So wait, why'd you do
Why
that?
does this not make sense?
The elimination of the subtraction sign.
Yeah, wait, why did you do that?
Because you have to know how these formulas work. The formula, by definition, it has to be X minus a number squared. That is the definition of vertex form. This doesn't say X minus. So the only way to make it X subtract a number and not change the meaning of the problem is it would have to be X subtract. X subtract what number turns to +3? -3. So now X is part of the formula, minus is part of the formula. Who's H? -3. The opposite of that number there. Yes?
The subtraction sign.
Now, I don't want you guys going through the hassle of, oh, Artie said I got to rewrite this. No, you don't. That is the reason it's not the number that's written there. I just want you guys to know it's the opposite. So you're going to look at that and say H is who? -3. The opposite of what number is written there. I'm just telling you why. If you don't like the why, then just take me for what it is. It is the opposite of that number. All right, so who's A in this problem? -2, which means our parabola is going to open up or down? Down. It's also your pattern number. H is what number? -3. The opposite of what's written inside there. And then K is? -4, meaning our vertex is -3, -4. Let's do it. Let's graph some. All right, here we go.
Where are we graphing?
Right below it. All right, now guys, you should time yourselves. If you are a pattern person, how quickly this is going to graph. All right, standard vertex form. Vertex, right? The parentheses, the dead giveaway. All right, I need A. Who is A, the leading coefficient?
-1.
We going up or down?
Down.
We're going down. We got a visual, and he is my pattern number. All right, now I need H. They wrote X minus 1, so I'm going to say H is just the opposite. And then K is 5, making our vertex the point 1, 5. We got it. Start graphing. We got the vertex. Put them on the graph. Give yourself some AOS for symmetry. Anybody know who the AOS is?
1.
X equals 1. Now you have a crossroads. A is a beautiful number. He's no fraction. You could pattern it. You could table it. So now if you're going to be a table person, I would put 1, 5 in. I would pick 2 to the right. I would pick 2 to the left. And then plug in whichever ones you want to plug in. I'm going pattern. The A is who here? -1. So let's get our pattern. Let's get our jumps. The parabola pattern goes up or down following 1A, 3A, 5A, 7A, 9A, so on. I only make you do 1A and 3A. So what is 1 times -1? -1. What is 3 times -1? -3. Let's do it. From the vertex, the pattern says you only move to the right how many? Just 1, to where the next X coordinate is. And now according to the pattern, we will be making how many jumps down first? 1. Boom, boom. That means anybody who went over to that table and plugged in 2 or 0, I'm telling you right now, you got 4 to come out. And then from this point, I'm going to go to the right how many? 1 to the next X coordinate. Now the pattern says to go down by 1. 2, 3. And 1, 2, 3, you're done. So when we know the vertex, we can put the parabola graph together super fast if we use the vertex and the pattern. And I'm telling you right now, if anybody plugged in -1 or 3, I'm telling you, they would have gotten a +1 to come out. Okay. Now, just for anybody, because there always are students who like their table, let me just show you how I would have plugged it in. And I probably would have gone 2 to the right and plugged in 2 and 3 and matched them. I would have wrote this, y equals -1 in front. You can either write the negative sign or the -1. Parenthesis, I'm plugging in 2. I'm subtracting 1. I'm squaring it, and then I'm adding 5. That's exactly what I would have plugged into my calculator, and I'm telling you right now, you would have gotten 4 to come out. That's what I would have plugged in. All right. I don't want to answer the silly questions right now. I hope you guys can answer every single one of those questions right now and know exactly what I'm asking for. The y-intercept is right there. Who is that point?
Put it as like x.
Put it at 0 and then
0, -4 at the ordered pair. All right, let's do this one. Let's keep going. Let's do it again.
Wait, it's 0, 4.
Oh, 0, 4. Did I say -4? Sorry, Jake. All right, here we go.
I'm smarter than you.
You are. All right, let's look at this one. Whoa. All right. Standard or vertex form. This is vertex, right? The parentheses are our dead giveaway. All right, let's do it. Who is A, your leading coefficient? 2. So is this parabola going to open up or down? Up, and that's your pattern number. You want to use the pattern, you're counting by 1A, 3A, 5A, A is 2. All right. H is who, if that's what they wrote? -6, the opposite. And now listen to what I'm saying. What number could they have written out here that represents nothing? There's nothing there.
0.
0. If they want to write 1, the only place you can assume a 1 is in front of something. I can assume there's a 1 in front of the parenthesis. I can assume there's a 1 in front of an x. But I can't assume that they wanted me to put +1 out there. They would have had to have put that. That changes the problem whether I add 1 or I don't add 1. So if they don't write something at the end, you've got to assume nothing's there at 0. All right, that means our vertex is the point. -6
here.
Done. Let's go. Start graphing. Left 6, up or down, none. All right, give myself some AOS for symmetry. Anybody know who the AOS is? X equals -6. So now you can put your vertex in your table and pick 2 x's to his right, -5, -4. Or you can pick 2 x's to his left, -7, -8, and start plugging them in. Or you can use the pattern. I'm going pattern. A is a beautiful number. A is 2. So I need to get my pattern set. 1A, 3A, 5A. Guys, what's 1 times A? 2. What's 3 times A? Let's do it. So from our vertex, I'm going to go to the right how many?
1.
Just 1. And up how many jumps first? 2 jumps. And then I'm going to go left 1 and match it, up 2. From there, let's go to the right how many? Just 1 to where the next X is. Now I'm going to go up how many jumps? X.
I went down.
If they're positive numbers, you're going up. If they're negative numbers, you're going down. And you're done. Okay? And again, if anybody wants to see it, if I was going to plug -5 and 4 or anything, I would have typed this. Y equals 2, parenthesis, -5 goes in for X, +6, close it, square. That's what I would have written. All right, the only thing I want to ask you guys right now is, what if you had to answer what the y-intercept
0.
is? Okay, hold on. Do you see the y-intercept on his graph right now?
Yes.
I don't.
Oh.
He's not a point on his graph right now. But we know his x-coordinate is who?
It's 0.
0. So guys, when you're in standard form, I love the y-intercept question. It's always C. This is not standard form. So if you want to find the y-intercept, there's no number in the equation it's always going to be. You just have to plug in 0 and see what number it spits out. So let's find the y-intercept so you guys can plug in 0 and see what number comes out. So if we found the y-intercept, we know x is 0. So let's plug 0 in. Y will be 2, parenthesis, 0, +6, square it, and hit
Wait
enter.
a second.
What?
What did you?
The x-coordinate of every y-intercept is 0. That puts it right on the y-axis. I have to plug 0 in to see what the y-coordinate is. Guys, we can do this. PEMDAS, parentheses, what's 0 plus 6? 6 squared, exponent's next. 36 times 2. 72 is your y-intercept. I like it. I just want you guys to be prepared that we can still plug zeros in and let the math find our y-intercept. All right, I'm going to try to do it before the bell cuts me off. Oh, Hardy, why'd you have to go there? Last one. Because remember, not all parabolas are going to be rainbows and unicorns. Let's make sure we know how to graph them all. That's vertex form. We're good. Who is A?
-1.
Negative 1/4. All that tells me is like, I'll probably just use the table here and let the calculator do all the work. All right, so A is negative 1/4, which means, is this parabola going to go up or down? We know it's going down, it's negative. That is your pattern number. It will still work. You just have to count by fractions. All right, H. Who is H if that's what they wrote? -2. And K is 6. So we got a vertex at -2, 6. Put it on your graph. Left 2 of 6. Give yourself an AOS to help with symmetry. And we got x equals -2. All right, I'm telling you right now, I've used the pattern before. I'm probably a little bit more comfortable, not as Jake, he's smarter than me, but a little bit more comfortable with fractions than you guys might be. I would just go to the table. Plug your vertex into the middle. Let's pick 2 x's to his right, -1 and 0. And let's pick 2 x's to his left, -3 and -4. And then you pick which 2 do you actually want to plug in, the 2 to his left or the 2 to his right? I'm going right.
Why don't you go higher?
Because I like it to be in order. That way the symmetry is shown.
I had mine at 0.
You can plug them in any order, and you're just going to get the ordered pairs. I like it because here you'll know the 2 to his right and left get the same number. The next 2 away to his right and left get the same number. It shows the symmetry. That's the only reason why I like to do it that way. That's it. Okay, here we go. So now I'm going to plug -1. So this is how I would type it in, guys. Y equals, we're plugging in -1. So that -1/4, here's your options. Some of you like that N over D button, right? So I would get a parenthesis, I would hit N over D, -1, put in 4, close it. That's how I would do my fraction with N over D. Or I just do this, parenthesis, -1 divided by 4, close it. That's my -1/4. That's how I'm going to write -1/4. I'm going to put it in parentheses using the division symbol. Now I'm continuing with this parenthesis. I'm going to plug in -1. I'm going to add 2. I'm going to close it. I'm going to square it, and I'm going to add 6. If you plug this in and hit enter, it does the entire thing for you. It's a nice decimal. Don't sit here and make sure you can do it when you're on your own. What'd you get? No. 5.75. So that means the point -1, 5.75, and -3, 5.75 are on its graph. All right, now plug in 0. I would type the exact same thing in, except now we're plugging in 0. So -1 divided by 4 in parentheses, that's my -1/4. Now I need this parenthesis, I gotta plug in 0, I gotta add 2, I gotta close it, I gotta square it, and I gotta add 6. Hit enter, this is actually a beautiful number. 5. So now I know the point 0.05 and -4.5 are points on this graph. And remember I told you guys yesterday, when A is a fraction, you tend to get these wider, like bowl-shaped parabolas, and then the bigger A gets, you get those taller, skinny ones. So now your parabola looks like that.
What?
All right? Now guys, watch this.
It looks like that.
Because when A is a fraction, they get wide. They don't grow fast.
Go 5. I don't know. I'm just.
-1, 5.75 is right here. -1, 5.75. 0, 5.
Oh.
Now, if I really, guys, A was negative 1/4, right? 1A, 3A. 1 times A is negative 1/4. 3 times negative 1/4 is negative 3/4. I go right 1 down 1/4 of a point. That's 5.75. I go left 1, I go down 3/4 of a point. Now I'm at a whole number. So the pattern works. You just got to be comfortable counting by fractions. All right. You do have a homework tonight on Vertex form. It's on quizzes because Delta Math was trash. I did not like Vertex form. It was all transformations, and I like that. So either way, your homework is on quizzes, and it's super, super fast. And you get 3 tries like normal. It's due tomorrow night, and then yesterday's homework is due tonight, if you haven't done that yet. Tomorrow we review.